So when we look at just the two numbers, you said this equals 2 1/4 of the time.
Would it equal 3 1/9 of the time?
All right. Well, what would it mean for it to equal 3?
Well, 1/3 of the numbers are divisible by 3.
Okay.
And so you have a third for A. A third of the time you're going to get a multiple of 3, and a third of the time you're going to get a multiple of 3 for B.
Ah, interesting. Okay. 1/9.
And for 4, would it be 1/16?
Well, yeah, it's the same idea.
Okay. So you think, and it turns out it's a little bit more complicated than this, believe it or not. But for the greatest common divisor to be 2, what do you need to have happen?
You need to have both the numbers be even.
Okay. So what could go wrong? What could happen when the two numbers are both even, but the greatest common divisor is not 2?
Well, they could be both be divisible by 4.
For example?
Well, like 4 and 8.
Yeah. So this is...
Because the cases overlap.
Yeah, that's the unfortunate thing, is you've got a lot of overlap in the cases. Sometimes when the numbers are divisible by 2,
they can also be divisible by...
They can also be divisible by 4. So this isn't quite right. It's this kind of the right idea. But we have to count this in a slightly different way. Okay? In a slightly different way. And the way to count it, you ready for this?
Mm-hmm.
Is to start by wondering, when does the greatest common divisor equal 1? So when are two numbers relatively prime?
When they don't have any common factors.
Yeah.
Well,
Okay.
if you have two numbers that are right next to each other,
Yeah.
like 8 and 9, or 9 and 10,
Okay.
then the numbers are relatively prime.
Then the numbers are relatively prime. Yeah. What's another example?
Well,
When you have...
like maybe 9 and 32.
Ah, 9 and 32 is a great
So
example.
all 2s or all 3s.
Okay.
Like, you could have all of one prime.
Mm-hmm. All right, cool. Well, what do we need to have happen then for a number to be two numbers to be relatively prime?
Well, we need to have none of the prime factors match up.
No factors match up, so no 2's together.
3s.
2's, no 3's, no 5's, all the way down to what? When do we stop?
At infinity.
At infinity. So nothing matches up. Okay? So,
Well, how likely is that?
yeah. So what's the probability that they have a 2 in common? So A has 2, no 2. B, let me make that chart a little bit bigger. A, so has a 2 and has no 2's when you factor it.
Yeah.
And then B I'll put up here. So 2, no 2's. That's what we have to figure out. So what's the probability that both A and B have a 2 in it?
Well, that was 1/4.
That was 1/4, because half the numbers have 2's and half the numbers don't have 2's.
Yeah.
Okay? So how can we fill in the rest of the chart?
Well, then the no 2's is also 1/4.
How come?
Because half of the numbers don't have 2's.
Ah, alright. How about B has a 2, A doesn't have a 2?
Well, then it would still be 1/4.
Why?
Because it's half have 2's, half don't. Half times a half.
Okay, and then can you tell me what this is going to be?
That's going to be a 4th.
How come?
Because half of them have a 2 and half of them don't.
Alright.
And all that together equals 1.
Okay, so now here's the challenging question. What's the probability that the greatest common divisor what's the probability that we have that 2 is not a common divisor?
Well, you'd have to look at these two cases. Or, well, maybe this one has some that could work too.
Because both have no 2s.
Ah. So what are the cases where, what do we need to have happen for there to be for 2 to not be a greatest common divisor?
Well, you need there to be either no 2s in one of them or no 2s in both of them.
Okay, so what's the probability?
3/4.
3/4. Okay, now we'll go ahead and look at no 3s.
Okay. Alright.